Hey guys, we're going to work on our solving absolute value equations flipbook. So you cut out all four pieces and then you just stack them in order from smallest down to putting the largest one on the bottom. So solving absolute value equations goes on top. The next page is this one you're seeing here, what is absolute value? The page underneath that is this solve by isolating the absolute value. And the very bottom page is solve by writing two equations. So you're going to cut that out. You're going to staple it together right at the top so it still flips open. And then I would wait until we're done to glue it into your interactive student notebook. I think it's hard to write on after it's glued. So I do all my writing first and then I glue the things in. Okay, so let's look at this first page. What is absolute value? So absolute value is the distance a number is from 0 on a number line. So for example, the absolute value of 3 is 3. And the absolute value of -3 is 3, because an absolute value takes any number inside and turns it positive or keeps it positive. So what we mean by that is here's 0 on our number line. Let's just put a dot where 0 is. Now, where we get the distance away, if you see this number in here, that was 3. Let's put a dot there. Notice I'm trying to color code again for you guys. That was -3. Let's put a dot at -3. All right, so what's going on here is from 0 to 3, the distance away is 3 units. It's up 3. And from 0 to -3, the distance is 3 units. It is down 3, but you don't think of it as -3. You think of it as 3 units to the left. You still move 3 units. So that's what it means by the absolute value is the distance a number is from 0 on the number line. So that's a super simplified example. Now, an absolute value equation is an equation that includes an absolute value expression. What they mean by that is there has to be an absolute value and it's equal to something else. So it could be like that. It could be super simple like this. We're just going to write down some examples. We're not actually going to solve anything. We're just learning how to recognize and say, hey, that's an absolute value equation. So here's a really fancy one. There's numbers outside the absolute value, like the 3 and the -7. There's numbers inside the absolute value, but there's still an equal sign. It could also be like 5 times the absolute value of x equals 12. So these are all just examples of what an absolute value equation is. All right, let's go ahead and look at page 2. So this should be the page just underneath that is solved by isolating the absolute value. And when you stack them, I'll attach a picture at the beginning of this, but you should see how you can see the titles because they're different lengths, so the titles still stand out. All right, so I'm going to use my highlighter a lot on this. You guys need to definitely get out your highlighter also. So to solve an absolute value equation, the key is isolate the absolute value. So what I want you to do on example 1 is I want you to highlight only the absolute value and the stuff in it. So we're going to use our highlighter a lot right here. It's going to really help you. So I've highlighted the absolute value of x. So now I need to isolate that, meaning get it by itself on that side of the equal sign. So what I'm going to do is I have +5. I'm going to subtract 5. So now I have the absolute value of x equals 11 minus 5 is 6. So now I'm going to highlight that absolute value again. I'm keeping track of where it's at. Okay, so now notice, you got to ask yourself, is the absolute value by itself? Which it is. It's all alone right now on its own side of the equal sign. So now, when it's by itself, what you do to solve, it's really easy. You just split it into 2 problems. So you have x, the thing inside the absolute value is x, equals 6. And then you do the thing inside the absolute value, that's x, and equals -6. So those are your 2 answers, are 6 and -6. Let's go ahead and try another one. So let's highlight the absolute value. I'm going to switch colors just so it kind of changes it up, but you can stick with one color. So highlight the absolute value in example 2, just the absolute value bars and everything inside of them. All right, so now you ask yourself, is the absolute value by itself? No. Okay, so what you're going to do now is you want to get the absolute value by itself. So you're going to add this 1 so that the absolute value is then alone. And what you do to one side of the equals, of course, you must do to the other. So you have the absolute value of y equals And on the right side, you have -1 plus 1. That's 0. So now let's highlight that absolute value one more time. So is the absolute value by itself? Yes. So now you can divide it into two equations. So you do y equals 0 and y equals -0. But hopefully you're like, -0? Miss Levan, that's not a thing. And you just cross it out because obviously you can't have a -0. So this one only has one solution, which is y equals 0, where example 1 had two solutions, 6 and -6. All right, let's go ahead and try one more. So let's go ahead down here at the bottom and let's highlight our absolute value, just the stuff inside of it. Don't highlight that 3, it's not inside the absolute value. All right, so we have to get the absolute value by itself. All right, so what we're going to do, we have a 3 and we have a -2. But remember, when you're solving, you use PEMDAS backwards, so you add or subtract first. So first, we're going to add the 2. All right, so I have 6 equals 3 absolute value W. Now let's go ahead and highlight that absolute value again. All right, still trying to get it by itself. So next, we're going to move the 3. It's multiplying times the absolute value, so let's divide. All right, so I have 2 equals the absolute value of W. Now, because I ran out of room, I'm going to rewrite it up here, but if you have room, keep going right underneath. So now let's highlight that absolute value one more time. And you remember, you ask yourself, is my absolute value by itself? It is, so you're ready to split it into two equations. So what we're going to do is we're going to have W equal to 2 and W equal to -2. So in this case, we also have two solutions. All right, let's go ahead and turn to the last page of the foldable. So on this last page, we're doing the same thing here. We're going to highlight the absolute value and make sure it's by itself before we begin into splitting it into two problems. So notice in our absolute value that I just highlighted, we have not just an x, but we have a 2x plus 5. That doesn't change how we approach it, it just has a couple extra steps. So the highlighted absolute value is by itself on its own side of the equal sign. So that means you can divide it into two problems. So the first problem is 2x plus 5. Those are all the things that were inside the absolute value in equals 13. The next problem is also 2x plus 5, but instead of equals 13, you have to do the equals -13. So it's going to equal the positive and the negative. Now, once you get it divided into two problems, you just solve it like normal. So I'm going to subtract 5. So I'm going to have 2x equals 8. And I'll divide by 2. And I will get x equals 4. So that's one of my solutions. Now come over on the right side and do the same thing. Subtract 5. But -13 minus 5 is -18. Then divide by 2. And you get x equals, sorry about that, x equals -9. Okay, so let's look at the next example. So let's go ahead, let's highlight our absolute value. Now notice, it's already by itself, so we don't have to do anything to get ready to solve the problem. But then also notice over here, it equals a negative number. So because of that -21, you're going to say that it has no solution. And we're going to put a little reminder to ourselves. An absolute value, I'm going to abbreviate here, can't equal a negative number. Now you can't make that decision to make it no solution until the absolute value is all by itself. Take a look back here on the previous page we did. Do you guys see example 2 right here? Do you see how the absolute value was equal to a -1? But it wasn't no solution. And the reason why is because I can't judge it until I get the absolute value by itself. So look here. Here is where the absolute value is all alone, and it no longer equals a negative number, and that's why I was able to solve it. So don't make your judgment and say no solution until the absolute value is alone. All right, let's look at example 6. So example 6, let's highlight absolute value and the things inside. So we can't start or make a judgment until we get it by itself. So we need to move that 2. The 2 is multiplying times the absolute value, so I'm going to divide. So I have absolute value of 13x minus 2x equals 7. All right, I can go ahead and simplify inside the absolute value because 13x minus 2x is 11x. So all I did was just simplify inside there. Now you ask yourself, is the absolute value by itself? Okay, it is. Is it equal to a negative number? It's not, it's equal to 7. So you can go ahead and you can do two equations. So you do 11x equals 7 and 11x equals negative 7. Get x by itself, oops, divide by 11, not x. So one answer is 7 over 11. And the other answer, divided by 11, is negative 7 over 11. And those would be our two solutions. So this is kind of a hefty section. That's why we're splitting it over 3 days to get really good at it. This is just the beginning. We're going to continue to practice. We're going to use this foldable on our notes. It's going to help us guide through our notes and through our next 3 days of work. So it's definitely worth your time to fill out. And I promise, although this is a little bit harder than what we've been tackling, we will get it by the time we're done with the 3 days of practice.